Have you ever really stopped to think about what's going on inside your computer? I mean, you click a mouse, you type on a keyboard, and stuff just happens on screen. But how? Well, deep inside, there's a tiny, powerful chip that's acting as the brain. And in this explainer, we're going to pull back the curtain and see how that brain, the CPU, actually works.
So this little square of silicon and metal right here, that's it. That's the Central Processing Unit, or CPU for short. It's the engine, the command center, the whole shebang. It's the part that's responsible for running every single program that makes your device come to life. Looks pretty simple from the outside, right? But inside, well, that's where a whole universe of complexity lives.
So, that's the big question, isn't it? How on earth do we get from a simple jolt of electricity to, editing a video or exploring a massive open-world game? It feels like magic, honestly, but it's all based on a few core principles that are actually surprisingly logical. So let's break it down. Okay, first things first. We need to understand what a CPU's job really is. At its core, its job is to process instructions. That's it. It takes in commands from all your software and then performs whatever operations are needed to get them done.
Now, the thing is, the CPU isn't just one single monolithic block. As you can see here, it's actually a team of specialized parts working together. The best way to think about it is like an office with 3 key players. You've got a manager, a brilliant mathematician, and an incredibly fast assistant.
So first up, we have the control unit, or the CU. This is our manager. It doesn't do any of the actual heavy lifting or the math, but it tells everyone else what to do. It fetches instructions from memory, directs the flow of data. Basically, it's the traffic cop making sure everything happens in the right order and at the right time. Next in our office, we've got the Arithmetic Logic Unit, the ALU. This is our mathematician. This is the real powerhouse where all the number crunching happens. Anytime your computer needs to add 2 numbers, or say compare if one value is greater than another, the manager, our control unit, sends that task right over to the ALU to get it done. And finally, we have the registers. This is our incredibly fast assistant. These are tiny, but super high-speed storage spots located right on the CPU itself. You can think of them as the little scratch pad where our mathematician is jotting down the numbers it's working with at that exact moment. Their speed is absolutely crucial for keeping the whole operation flying along. Okay, so we've met the team. How do these 3 parts actually work together? Well, they follow this constant, relentless rhythm. It's a fundamental process that's literally the heartbeat of the computer, and it's called the fetch, decode, execute cycle. This diagram here shows that rhythm perfectly. For every single instruction your computer runs, the CPU performs this 3-step dance. It fetches the command, it decodes what that command means, and then it executes it. This cycle is just a continuous loop, and it's the fundamental process powering everything from your operating system to your favorite game. Let's just walk through it real quick. First, the control unit fetches the next instruction from your computer's memory. It knows exactly where to look thanks to a special register called the program counter. Think of it like a bookmark. Second, it decodes that instruction, basically translating it into a set of signals the CPU can understand. And finally, step 3, it executes the command, sending those signals to the right part, like the ALU, to do the work. And here's the part that's just wild. We are not talking about this happening a few times a second. Modern CPUs can perform this entire cycle billions of times every single second. That's faster than you can blink. It's this absolutely incredible velocity that creates the smooth, instantaneous experience we've all come to expect from our devices. Okay, so we've seen the high-level process. We know the what. But what are the ALU and the control unit actually made of? How do they know how to do anything? To understand that, we have to zoom way in, down to the physical building blocks. So these big components, they're constructed from something called logic gates. A logic gate is just a tiny circuit that performs a very simple logical function like AND or not. So for example, an AND gate will only output a yes signal if both of its inputs are also yes. It's a really basic decision maker. And you guessed it, this takes us one level deeper. These simple little decision makers, they themselves are built from an even more fundamental component, the absolute bedrock, the foundation of all modern electronics. Transistors. A transistor is just a microscopic switch. It can either be on, allowing electricity to flow, or it can be off, blocking it. And this simple on or off state, well, it perfectly represents the 2 digits of binary code, 1 and 0. That's it. That's the foundation of all digital computing, a simple switch. And here's where it gets truly mind-blowing. Thanks to some incredible engineering, we can now pack billions of these tiny switches onto a single CPU chip. Billions! It's just staggering. All of those simple on-off switches combined into logic gates, which are then arranged to build complex circuits like the ALU. It's immense complexity, built from utter simplicity. Now, having a super-fast processor is great, but it's totally useless if it's constantly sitting around waiting for data to work on. So the final piece of this puzzle is memory. The CPU needs lightning-fast access to the instructions and the data it's working with. And this pyramid here, it's the perfect way to visualize the memory hierarchy. It's really a pyramid of trade-offs. At the very top, you've got those super-fast registers we already talked about, but as you move down, the storage gets much bigger, but it also gets slower and cheaper. It's all about balancing speed, size, and cost.
2 key levels you really need to know about are cache and RAM. Cache is a small amount of superfast memory that's built right into the CPU. It basically stores frequently used data to avoid making that slow trip out to the main memory, or RAM. The analogy here is perfect. Think of cache as the documents you have on your desk right in front of you. RAM, on the other hand, is the entire library down the hall.
So, let's take a step back and see how this all connects. Let's tie it all together, from a single tiny switch all the way up to a fully functioning computer. So let's connect all the dots. It all starts with billions of simple on-off switches, our transistors. Those switches are arranged into logic gates that make basic decisions. Those gates then form our key components, the manager, which is the control unit, and the mathematician, the ALU. Together, they run that fetch, decode, execute cycle at unbelievable speeds using fast cache memory to avoid any delays. And that entire chain, from a simple switch to a complex cycle, is how your CPU turns a stream of electricity into everything you see and do on your screen.
It's an absolutely incredible system of nested complexity, where billions of simple little parts work together to create something immensely powerful. Which really just leaves us with a final thought. If today's CPUs are already this complex, built from these simple switches, what does the future hold as we get even better at arranging them? What new possibilities will that unlock for what computers can think about?